Hello everybody. In this video we will build a simple deep learning model, and we will be using cancer diagnosis datasets that I have downloaded from Kaggle. You can download this datasets from Kaggle, or I'll leave them both this Python file and the CSV file which I'm using in this video on our GitHub page. Okay, so let's begin. Again, this is going to be a very introductory level machine learning project. So let's build this. So let's import some of the packages here. So import pandas, and we need numpys, we need Keras. So we'll be importing them from TensorFlow. We need Seaborn for data visualizations. So Panda is going to be our data analysis package. NumPy will help us build and manipulate and calculate all those ideas related to arrays. So let's begin. Let's import our data frame. Let's create a data frame. So we're going to be using the function from Panda, read CSV functions, and we're going to have our file here. Right now, my file is in the same folder as my Python file, so cancer diagnosis file. So that's why all I had to do was enter this. If you don't have it in the same folder, either you bring them into the same folder, or you could provide the exact path links. Okay, so let's read the first three line, maybe three line. Okay, let's look at the first three line. Okay, so you can see here it has 33 columns here and 3 rows because I put 3 over there. If you don't put anything there, it's gonna read 5 of them. Okay, so let's do a couple of things here. Let's look at few things that you can see here. It has a bunch of columns. Let's find out which columns are not important here. So we have ID. So these are just an ID for each samples. Then we got a bunch of different ideas. So we got radius mean, texture mean. So these are all the numerical data for cells. And then we got a few of them here, unnamed 32. So these are basically some of the null values. So we gotta get rid of this column here, unnamed 32. Okay. You can check more details about this by something called dataframe.info. Oh, sorry. We gotta enter the bracket. Okay, so now it has, you can see here, it has 569 entries, and the column 32, unnamed 32, has 0 non-null values, which means everything is in that column is null. I don't know how it's sneaked in there. So let's clean this up. So and everybody else has pretty good. So you can see here it has 569, and everybody has 569 non-null values. And we got the data types, object, float 64, int 64, and so on. So let's delete. So data frame dot drop, and we're gonna columns equals to, so this one would be a list because we're gonna be dropping multiple columns. So first column we will drop is ID, because ID is irrelevant, and the next column we'll be dropping is our unnamed 32 right here. So unnamed 32. And one thing you want to do is in place equals to true. So this means it will replace our the original data frame. So it will drop those columns and it will replace the old data frame with this new data frame. Okay, so now you can check data frame.head 3. Okay, so you see the ID column is gone, and also the unnamed 32 column is gone as well. Okay, so now let's look at here. So we have a bunch of data here. So we will be using this to decide whether our diagnosis is malignant or benign. So this M stands for malignant and there will be a benign. I'm just telling you because I have seen this data before. But how can we figure out what are the type of variables we have here? So let's do something. Data frame, and you want to look at the diagnosis column and then do something called value counts. Okay, so value counts will show us exactly how many types of data we have. So you can see we got two types of data, benign and malignant, B and M, and see how many of those are benign and how many of them are malignant. Okay, so this looks pretty good here. So let's try split our data sets into X and Y. Okay, so let's see, X gonna be, so your X data set will be data frame drop, and we're gonna drop the columns. The columns is gonna be diagnosis column. Okay, so whatever left over after dropping the diagnosis column is gonna be our X data sets. Okay, that's our X variable, and Y variable is gonna be basically the diagnosis column. Okay, so that's our X and Y. You can check the X. So you can check the X dot head. It is still a data frame. So you can see it has 30 columns and everything else except that diagnosis column from here. And you can check Y is also a series. You can Y dot head, and so you can see the first two elements there all. You can do first 5 as well. So all of them are malignant. Okay, so that looks pretty good. Our X and Y is looking pretty good. Okay, next thing you want to do when you are doing a machine learning project is you gotta scale all of your X variables right here, all of these categories that we have. So you can see here we got 17.99, and then you got 122.8, 1000.8. So these are all different range. So if you don't scale them properly, they all gonna have a positive or huge negative impact on your model. So let's scale them. We can scale the data sets using scikit-learn's package. So from sklearn.preprocessing, I'm gonna use standard scaler. That's pretty good. And another thing I will need is label encoder. This is something we will need to convert this M. So these are object data type, right? Diagnosis is M. So these are strings. So now we're gonna convert this into numerical data sets. We're gonna create a label. So that's why I have this label encoder as well. Okay, so let's do those. So let's start with standard scaler. SC equals to standard scaler. Let's create an object, and what I'm gonna do is I'm gonna do sc.fit transform. So we'll fit and transform our X variable. Okay, so X, and you can see print X. You can see the first rows for this column. See how it looks. Okay. Oh no. Oh, I did a stupid mistakes. So let's call it X equals to this. Okay, so now you see all the data sets from the first row has been converted into an array, and they are all scaled properly. Okay, so now everything's good to go for X data sets. Now next, let's change the label. So we know we have two labels, so let's do LE equals to label encoder, and we're gonna do Y equals to LE dot fit transform as well, and we're gonna pass our Y variables, and you can print it Y. Let's print it out the first 5. Okay, so you see it's converted all the M to 1. So you can see the first 5 data sets of our y were m, so all the m's are y. So it goes alphabetical. It goes b is gonna be 0 and m gonna be your 1. If you want, you can check it out. So le dot classes right here. If you put this, it's gonna show you the arrays that uses. So this is your 0, this is your 1. If we had more in our list, then it would have been 0, 1, 2. So it usually goes with alphabetical. So you can do le dot classes. Okay, so I think we have done pre-processing. Okay, so next thing here in our white data set is one-dimensional data sets. We gotta convert into a binary matrix with 2 dimensions. So we can do that by Keras. So let's do this. So y equals to Keras dot utils to categorical. Again, we're going to be passing our data sets as y, and num classes is going to be 2. So basically what it is doing is let's print out y, and we're going to print out the same 5. Okay, so you see it's just converted into a 2-dimensional matrix. So the 1 here, that means it has only 2 data sets, 0 or 1. So when you have 0, this column would be 1 and this column would be 0. But since we have 1 here, so all of this, the second column is 1. Okay, so this is we created a 2-dimensional arrays from this. So this is going to be important for our machine learning work because our output gonna be either one of these two. Okay, so we have our x and y. Okay, so I think we are good to go. All we need to do is split our data sets into training and testing data sets. Okay, so let's go with that. We're gonna be using scikit-learn again. And model selections will have this import train test split. For this one, x train, x test, y train, y test is gonna be train test split. Now our data sets are x, y, and then our test size, we're gonna do 25%, and we're gonna be shuffle equals to true, and we're gonna pass it random state 69. Okay, this looks good. Everything split it equally. Okay, so we have split our data. So now we will build our deep learning model. So we will import few things from keras.model. Let's import sequential. So we will be using a simple sequential model, and let's import some layers from keras.layers. Import. This is gonna be a basic deep learning model. So it's gonna be we're just gonna have dense, dropout. Yeah, those are the only two things. You can do batch normalizations, but since this is a very introductory deep learning model and it doesn't have too many data sets to begin with. So if you've seen, we have only 569, if I remember correctly. Yeah, 569 data sets. So it doesn't have a too big of a data set. So we don't need batch normalizations or any fancy stuff. So we'll just do a basic. Okay, so we have everything. So let's do model. Let's create a model object. It's gonna be sequential, and let's add a couple of layers. Model dot add. So first layer would be our dense layers. So it's gonna have how many units? So we will put 32. Again, you can do whatever you want. 32 works, should be fine. Then that's how many input layer we're gonna have. And then let's do activation function. Activation function is, we will use ReLU activation functions. And then next thing we will need is input shape. It's gonna be, so how many shapes, what are the shapes for our x variable. So if you notice, let me show you x train dot shape. So you see it has 426 data sets, but out of then it has 30 columns. So those are gonna be your input. So you are training based on this 30 different classes of data that you're trying to use those data to classify whether you have cancers in benign or malignant. So we just need that number. So you could do the shape can be do 30 as your shape, input shape. Instead of writing 30, we can be a little bit more, we can write x train dot shape, and I want to use the index, which is the last index. This is the last index, right? Or I could have used 1 too. Okay, so this gonna be is our shape of our first layer, input shape. So then model dot add, then let's add a couple of more dense layer. We're gonna add 32. Activations is gonna be ReLU. Input shape. We don't need any more input shape anymore because it's already connected. Let's model dot add. You can add a dropout. So let's drop out 20% of our data. So dropout is gonna be 20%. Then we can add another layer if you want. This would, like, if I would have left as here, this would have been worked perfectly. But this is not a very compute intensive model. So we have the luxury of going one more layer. And I'll add another dropout. So adding dropout are critical because then you won't overtrain your model. I'm gonna drop 50% of the random lead will drop out. So this is, I'm testing. I haven't done testing with this type of architecture before. So we'll find out how good is our model. I have done up to this much. So I'm adding 2 extra layers. Let's see how it functions. Okay, now we're gonna have our output layer, model.add, and our output layer would be a dense layer, and it's gonna have only 2 units because our outputs are, it could be benign or malignant. Okay, and our activation function is gonna be softmax. That's for output, so you should always use softmax. Okay, so our model looks pretty good. Let's compile. We're gonna compile. We're gonna use optimizer as Atom with the basic learning rate. Loss functions here. We can use actually binary cross entropy here because it's binary because we have only 2 outputs, right? So it can be either 0 or 1, right? Or if you have more than 2, you could use categorical cross entropy. So like by default, you can always use categorical cross entropy. Okay. So let's do metrics. We're gonna have our matrix would be accuracy. Okay, so we got our accuracy as well. Let's summarize our model, see how many parameters we got. Okay, we got only 3,000 parameters. So if you have seen my previous Twitter video, deep learning with Twitter data sets, you can see that it has about 700 or million parameters, something like that, like 700,000 or 1 million parameters. But anyway, so I think this is gonna be super quick training. Our everything looks good. Okay, so let's just finalize it. So let's fit our data, model.fit, xtrain, ytrain, and batch size. Since we don't have to provide batch size, but because it is a very small data set, right? So you can put 200 at a time. It doesn't matter. I could go 1002, and batch size is good. Epochs, how many epochs we want? let's train this for 50 epochs. See if we can do, this is going to be really fast. I'm not doing a validation split on this one because our data set is already too small. So if I split it, it's going to be even smaller. Last thing is verbose equals to 2, and let's find out model.fit x train y train basa. Okay, so see, it's finishing super quick. We already finished. So our accuracy becomes 96, 97, 97. So it's flattening out around 96, 97. See, we could have stopped at 22, like 25 would be ideal. Like it's maxing at 25, right? It's fluctuating from there. So the last 25 epochs were not beneficial. It probably overfitted. Oh, well, let's see. Now we're gonna go into predictions. So our predictions would be model.predict. And we're gonna predict on our X test. And let's print our predictions. And we're gonna print first 5. And then I wanna convert these predictions into one-dimensional data argmax. And we're gonna have predictions. So it's gonna take the prediction that we did and find the maximum location index for each one of them. And axis is gonna be -1 in the last axis. Let's print it out again. We will print out the first 5 again. So there we go. Okay, so we have first 5. So you see it took these two, which index has the higher number. The higher of these two is the second column, right? The first column and second column. And we know second column is 1. So that's why the output is 1. If you look at the fourth one here, between these two, which column has the higher value? The first column has higher value. So the argmax takes the index of those two, whichever is the highest. So in this case, the 0th column or the first column here or 0th index column has higher values. Okay, so that's why the output is 0. Okay, so these are our outputs 1, 1, 1, 0, 0, 1, 1. Okay, let's do one last thing, actual. We have our y test, right? So we gotta convert that as well, argmax. And we will be using y test axis equals to -1. Like you can do it yourself, print y test. Let's print it out before. Let's print out the first 5. And let's print out actual. And again, the first 5. Okay, so you see it's converted this one, two-dimensional arrays into one-dimensional arrays. So it took the index, the highest of these two columns, in this case 0 and 1. So which index has the highest value? The second column, which is index number 1, and its output as 1. And if you notice here, highest of these two is the first column is 0th index, so that's why the output is 0. Okay, so we have converted our series. It looks like our actual here matches with our prediction, so it seems like our model is doing pretty good. So let's find the accuracy score from sklearn metrics. Let's import accuracy score, and I like to have a nice confusion matrix too. Let's say AC score equals to AC score, and we're gonna have actual and predictions, and we're gonna print AC score. Okay, we got 97% accuracy, which is pretty good. And let's have our confusion matrix. So let's call C matrix is, and we do the same thing. You gotta put the actual data sets and prediction data sets, and let's print out. EM. Oh no. Oh yes. C matrix. I have I always put CM when I'm coding. Okay, so it looks pretty good. So let's print this data into a nice looking graph. So let's create X. Let's create axis equals to, we're gonna be using SNS. We'll create a heat map, and we're gonna be using our data sets. It's gonna be confusion matrix. We want to unnote, and we're gonna be using DC map. We're gonna be using, let's use greens this time, and X tick. Let's print out. Okay, this looks pretty good. So it predicted 0 and it turns out 0 as well. So it looks pretty good. So let's add, make this graph slightly better. So let's create label, create a list. So if you notice our, if we go up here, where did it? Oh, here. So our 0 stands for B and 1 stands for M. So B is benign, M is malignant. Okay, so 0 and 1. So let's create a label is benign, and malignant. Okay, let's add a couple of details here. So our X tick labels is gonna be label, and Y tick labels is also gonna be label. So now our graph will have this benign. So it predicted 77 to be benign, and it's actually okay. Let's add a couple of more things. So AX dot set title. Set title, we can add title here. So let's call it confusion matrix for cancer diagnosis data sets. I know it's a long title, but why not? It's not costing us anything. And let's put set X label, and we're gonna label X level as actual. Sorry, X tick is predictions, and AX dot set Y level is gonna be our actual. And boom, our data sets looks pretty nice. Maybe you can bring the font size of actual and prediction slightly bigger. So you can put font size equals to whatever, 14. Let's add font size equals to 14 as well, and looks slightly better. Yeah, this looks pretty good. So it predicted 77 times to be benign. It is 77. 62 times to be malignant, and it is 62 times. So I think the scaling of the data sets works perfectly. So you can test this yourself without scaling it. So remember, we did standard scaler. The standard scaler did the magic. Try doing this without standard scaler, and you'll find out with the same model, this would be pretty bad. Okay, let's do one more testing since we are doing, maybe we can remove this to excess calculation. See if our model is still good. Okay, I'm just gonna say our model has 97% accuracy, and I am gonna redo this thing again. So by deleting a couple of layers, see if we get the same. Okay, we had before 3170. Now we got only 2000 parameters. And let's clear the output from this cells. Current outputs clear. Let's clear it out and see. Let's refit this model. Okay, we started 37. Okay, so we got to get 97, 98%. Maybe it's overfitting. We'll see how the predictions is doing. Okay, so we'll predict again and print this. Let's print the accuracy score. Okay, it's didn't do bad. Like it's still 96%, 97 if you want to round it up. So it's like that extra step probably didn't help too much. Okay, so we went from 77 to 76, so that's probably why. Okay, so it looks pretty good. By removing that extra step here, we didn't lose too many of our accuracy score. Yeah, that's all I had for this video. Let's see what can I do for our next video. I'm still thinking what would be our next video. I think the next video will be a tutorial on RDKit, and I'll be using a couple of new packages, which is called DeepChem. DeepChem is a package for obviously for Python, but this is for more chemical and biological science. So I'll start with the next video will be an RDKit tutorial on Pythons. Stay tuned.